Hi, welcome to another episode of The Retronaut. So, if you've been following the series, you would have so far seen that I made a dash to Worcester to collect this machine from its previous owner. It was originally used as a broadcast piece of equipment for Central Television in Birmingham, which is part of the ITV network in the UK. And then there was a journey back home where I was wondering about what I was going to find when I actually looked inside this machine to see, if there was any damage, because I knew that these machines tended to have battery damage, but I just didn't really have any idea, what I was going to find. In that first episode, we then looked at the footage of when I inspected the outside of the case, and then eventually I went inside and I started to disassemble the machine and have a look at what I could see inside. I'm going to actually go back to that footage in a moment, and we're going to have a look again at it in a little bit more detail to see if we can actually ascertain what the problem was with this machine. Why wasn't it showing any video whatsoever when it was turned on? So a quick introduction to the Amiga 4000. If you're not aware of this machine, I'll give you a little breakdown of how it works. This is the main logic board. You have an expansion board here, which has slots in it, which are called Zorro 3 slots, which was the ultimate version of these expansion slots for the Amiga range of computers. 32-bit wide, high speed. I think they do DMA as well. And then over here, you've got a daughter card, which actually contains the processor for this board. So by default, obviously, this machine has no processor. You must have a daughter board with either a 68030 processor or a 68040. I was very lucky in that the one I purchased had a 68040, and that's it here. And this was until Commodore was bought by Escom. This was the fastest processor that you could get in an Amiga back in the 90s, 92, 93. The logic board has a slot here, which is where the riser card goes in. And it would obviously plug in like this. And then that would give you then 4 Zorro 3 slots, which can have things like graphics cards, SCSI hard disk controllers, and various other devices. Memory as well. You can actually fit memory to the machine like this and actually expand this particular machine up to quite a large amount of memory for the time. I think 256 meg is the maximum. I'm not sure about that, but I think I've seen that bandied about. So yeah, that's the Zorro 3 riser card. And then what is it about these machines that tends to break? Well, there's a common scenario, which is that the battery, which would be here, tends to leak. People don't realize this. They have the machines back in the 90s. They put it in a cupboard. They put it in their loft, in their garage. They leave it there for 20 years. They have no idea what's going on inside. Obviously, they're completely oblivious to it. And after a certain amount of time, which seems to be a bit random, I have a feeling it has to do with the environment, because I've seen, these machines with very, very bad leaking from the battery, and I've seen other machines with no leaking, and I've also seen machines with moderate amounts. So there must be something different, right? Is it the temperature? Is it the amount of moisture in the air? I'm sure it's got something to do with that, maybe. So if you keep it maybe in a loft, in a warm loft, maybe it has one type of behavior, and if you keep it in a cold loft, maybe another. Maybe, I don't know. I don't know if it's moisture or anything, but you definitely see a range of different levels of damage in these machines. So I was wondering, did it have no damage whatsoever? This can happen sometimes. Did it have a mild amount of damage, or did it have a lot? And if you watch the first video, you would have seen that we looked at these, the joystick and the mouse port here. And a really good indicator that the leaking isn't so bad is when these don't have any corrosion, any visible corrosion on the outside. That isn't a guarantee, because the machine could be kept in a terrible environment anyway, and the entire board could have oxidization on it. But that is one of the ways that you can kind of get an idea, what's going on inside. If the machine looks very neat and there's no rust on the outside, but then all of a sudden you see a lot of corrosion here, that gives you an idea that you've got a leaked battery. So let's go and have a look at that footage now, where we are. It's still, I think, the same day as I actually bought the machine. And I'm quite excited. So I was like, flying around this with my camera, having a look at different parts of it. And I didn't really do any sort of in-depth analysis. But if we actually slow down the footage and get some stills from it, we can actually see that there are some issues. So yeah, let's have a look at this area here in a little bit more detail now. So if you remember in the rescue video, we looked at this footage already where I've got home, I've opened up the machine and I'm having a look around to see what's going on. And in this image, you can see the red battery there, the Varta battery, I think it is. Things actually don't really look that bad at this point. I should point out some general things that you'll see. The logic board is quite dirty. The 3 chips in the middle bottom of the view there, they actually have some brown stuff on them, and that's actually just dust. And I think what's happened is the dust has maybe soaked up some of the electrolyte from the battery, and that's why it's got that kind of brownish color. It just looks a little bit dirty. In other parts of the board, the dust is more light colored. Do you see to the right of the battery? There's some fluff there, and you see it's white, but to the left of the battery, it's brown. So I think that fluff actually did a good job for us. I think it actually soaked up some of the electrolyte and stopped it spreading maybe and getting onto the chips themselves. So I'll just point out a few things here. Number one, if we look at the battery itself, you'll see that the plate on the left-hand side doesn't really seem to have much corrosion on it. And in fact, I can't see any electrolyte coming out of the battery there. So that might give us an indicator that, the problem is in a different location. If you look in general, you'll see that there is actually corrosion going on. You can see green on different areas if you pay attention, and I'll highlight those in a second. But yeah, to the left of the battery, I'm not really seeing much. So I think that indicates that the leaking, if there is any leaking, is maybe on the other side. So we'll have a look at that in a second. So at the bottom of the picture, there are a set of resistors, and they actually work with, I believe it's the chip just above them in the middle there. They are then connected to the left. You see there's a header there, a bunch of different headers. That's actually a configuration system that seems to be built into this board, which wasn't really that much used in the end. If you actually look at that header, there's nothing on it. There's nothing actually, shorting out anything. But it's actually still quite critical. Even with the default settings, if any of those resistors aren't working, you can have weird things going on. I think it's with your Lisa chip. You get, the machine thinks you basically have the wrong Lisa chip and you get weird behavior. I believe those chips there also can cause failures with your mouse and your joystick as well. So that's a common set of failures you can have in that area because of those chips there. The one directly to the left of the Varta battery, that's actually got something to do with your system clock. So if that's broken, you're probably going to find that your machine is just going to black screen and not work. Directly above it, there's a resistor pack, which in my case doesn't look too bad. Actually, I don't really see much green there. And then directly above that, the Ricoh chip, that's actually your system. Well, that's the real-time clock, I should say. That's the chip that actually tracks time and then records it. And the battery would normally keep that powered up to keep your time intact. If we go over to the right and we look at the Varta battery, you can see that directly above it on the board, there is a capacitor. And then above that is a chip, the 74F5245, which is an octal transceiver as far as I understand. That chip is very important because it's actually involved in controlling the fast RAM of the A4000. So if there's a problem with that, you're probably going to find that you've got some issues with your fast RAM. If we go and have a look at, for instance, the resistors again, that's a row of resistors. On the left-hand side, you see there's green rust, you can see there. So it shows that there has been some kind of electrolyte that's got into this area and it's caused a little bit of rusting there. And there are a set of traces just below it. So that's obviously a little bit of a concern. Has the electrolyte gone into those traces and caused an issue? Has the electrolyte gone into the chip just to the left of the Varta and damaged that chip? That would obviously cause the system to not work very well. The same thing up there with that capacitor just above it. Is there a problem there? Looking around, I don't think there's really that much more I should really point out here, except that maybe by the octal transceiver, I don't know if you can see there's a little circular shape there. That's actually a via, and just below the octal transceiver, you can see, I think, 3 vias, and they actually have traces that go to that chip and then connect that chip to a bunch of other chips underneath the motherboard. And I don't know if you can see it there, there's quite a lot of green. Obviously, that's a big problem. That's a very important chip, and the vias look like they've been badly oxidized. So if they're badly oxidized, then that probably means that the capacitor right next to them has had a problem as well. Obviously then to the right of the Varta, you can see you've got one of the RAM SIM slots. So that's pretty vital as well, obviously. You don't want your SIM slot to be damaged in any way. So yeah, let's change views. And this is another still from that video. Apologies because it's not particularly, it's in focus, but it's actually, there's a bit of motion blur going on because I was moving around, and you don't really see this side of the battery at all in any other parts of that video, but you can see it here. And if you look at the battery, do you see that sort of crystalline white looking stuff? That's electrolyte. So it's actually on the right-hand side of the battery that we've got some electrolyte coming out. And if you look at the bottom of that plate, which is holding the battery on, you'll see there's quite a lot of green there as well. So that indicates that the leak on this battery is definitely on the right-hand side. And we've got to be worried that, you know, there's going to be a lot more corrosion on the right-hand side than on the left-hand side. Again, if we look behind it, we see the octal transceiver, and now we can see the right-hand side. And again, we can see there is actually some green there. So that's looking pretty worrying. And the other thing I would say, it's not so clear from this video, but if we look at the left-hand side of the first SIM there, you can see to the right a little bit, there's a bunch of silver pins. And then to the left, there are a bunch of pins that look a bit green. So that's quite worrying. Maybe the electrolyte has crept its way up the pins of the SIM socket and managed to get onto the actual SIM as well. Yeah, so that's a bit of a worry. Let's move over to another image. So now I've actually got a bit of a view there, and I'm just using this to show you again where that octal transceiver is. You can see that all of the wires underneath it, close to the capacitor there, they're all looking really green. So that's not a good sign. That's really bad oxidization. What can happen is if those traces have basically turned into oxide, there won't be any connection between this chip and where it's meant to go off to. So that seems to be a little bit of a focus for me. I think I need to look at that and see if that's actually a big issue. And then this image, this is actually further up the board. We were looking in that direction in the last image. This is the SuperBuster. This is involved in connecting the A4000 to the expansion Zorro riser that we showed you in the intro. And yeah, very, very important chip. And I don't know if you can see it, but the wires to the right of it, the little circular shapes there, they're where the connections from that octal transceiver actually go under the board, and they come up here onto the top of the board. So there's a bit of a sort of burrow. The signals come out of the octal transceiver, go to the underside of the board, travel across the board, and then come back up here. And you can see here, they're quite green, those little ring shapes. And even more worryingly as well, if you look further up the board, you'll see that the wires on the other side of the SuperBuster look a bit green as well. And there seems to be some sort of powder there. So that's indicating that there's been a little bit of corrosion there as well. So these areas definitely need to be looked at in a bit more detail. They may not be broken, but they definitely need to be cleaned with vinegar. You know, we need to make sure that these areas are not going to have any more corrosion because they may have actually survived. And the last thing we want is for these to carry on oxidizing. So in that recap, we saw there were definitely some worrying signs. There's obviously signs of major corrosion around the battery area, and, you know, that's not really surprising. I'd just come back from quite a long drive, and I'd, you know, done this inspection of the machine, and so I decided to go to bed for the night and, you know, clear my head and see what happened the next day. Okay, and it's the following day, and I've managed to take out the Zorro 3 riser card, which is great. And I've had a look in here, and I don't know if you can see it there, but there's a little bit of green. So basically what's happened is the electrolyte has come out of the battery here, and it's gone down in this direction. It's hit the SuperBuster. There's a bit of green in here as well. I haven't taken it out yet, but I do need to take it out, and I need to clean it to stop any further corrosion. It's not easy, obviously, because it's one of these packages, but I do have a chip puller, so I'll have a go at that a little bit later. Yeah, so yeah, you can see there's a little bit of green there. And I've also managed to get the CPU out. Here it is over here. And based on Chris Edwards' videos where he recapped one of these, I've looked at the capacitors on it, and the bases of them seem quite cloudy. You know, it's not shiny metal, so that kind of indicates that there is leaking going on. I don't know how bad it is. It's actually, it doesn't look too bad, so it's the beginning of it. It's the same luckily with all the capacitors on here. There doesn't seem to be a great deal of leakage, but you know, these are known to leak, so I will have to maybe buy a defunct board and then have a go at replacing those caps, and then this will have to be recapped because it's a known problem with these Amiga 4000s that they leak. Apart from that, between the slots, I don't know if you can see it, quite a lot of green there. I'm not really sure if any traces have been lifted. The big difference between an Amiga 2000, for instance, and a 4000 is the size of the traces. They're so much smaller. So let's just pause here a second, because this is a great view to see the damage that was actually caused by the battery. If we look at the battery at the top there, you can see the discoloration in the board, and that light discoloration has come all the way down to the capacitor underneath it there. And I don't know if you can see it, but there are 3 traces that run left to right behind the capacitor. Can you see those? They go from the left behind the capacitor, and then they bend around a corner, and then they go off to the right past the Ricoh chip. Those traces are almost certainly dead. I don't know if you can see there do seem to be gaps in it, and the rest of it does actually seem to be, vibrant rust, basically. I haven't gone very heavy duty at this point with the fiberglass pen. At some point you have to, because you really got to make sure that you get rid of the oxidization. And sometimes when you have removed that oxidization, what you find you're left with is nothing, that the traces are gone. So I think that shows some real concern there. And if that's bad, what's going on with the wires that actually feed power to that capacitor? On one side it's ground, on the other side it's 5 volts. And if either of those is broken, then the capacitor is not going to work as it's intended to. So that could be a problem. If we look at the octal transceiver, that's the chip there, which is upside down, and it says 74F245. It's actually one of the main chips for getting the fast RAM to work. That looks like it's toasted, at least on the side facing the capacitor. Can you see the wires feeding it? They all have massive amounts of corrosion on them. There's loads of nodes of green, and they're looking quite puffy, quite raised. And that puffiness is actually the oxidization. It's not the original copper. I suppose that as it oxidizes, it combines with the oxygen and it gets bigger, right? Rust is always bigger than the original metal. So yeah, that's looking really quite bad. If we look a little bit further down past the octal transceiver, we can see there are several traces there to its right and a little bit lower. The wires there look really bad, and the traces there look really bad as well. So I've got a lot of concern about those. They need to be tested. And then to the left and down from the octal transceiver, looking underneath the SIM slot, can you see there's a bunch of wires there that disappear under the SIM? They're looking terrible. They're all lumpy. And I don't know how much of that is oxidization, but it's not looking good. What I found with oxidization sometimes is it can look incredibly bad, and then you clean it and it's not so bad. And in other cases, it looks okay, and you clean it and it turns out to be terrible. So at this point, I wouldn't have really known what the damage is, but it definitely, there are several areas around here where we've got some major concern, right? And therefore, they're also very fragile. The Amiga 2000 is actually quite a lot more robust, really, because the traces are so much bigger. So yeah, there's quite a high chance that there is some damage in this area. What I'm going to do today is I'm going to carry on cleaning up. I did bathe it actually last night in Deoxit. Other deoxidizers are available, of course. But I just thought it would be a good idea to... I washed it in vinegar, then I bathed it in alcohol to try and get that off. And then I put Deoxit on it overnight. And that's actually part of my method. When I finish here today, I will deoxit it again and leave that as a residue on it. And hopefully that will sort of help stop any further oxidization. So yeah, so the plan for today is clean it a little bit more, put it back together, and I'll try powering it up and see what happens. Got the power supply there ready to go. So yeah, wish me luck. So that recap of the inspection that I did when I got the machine back, that gives you an idea of the kind of inspection that then went on over the next day or so as I really sort of dug into what I could see going on with this machine. Obviously, it's very worrying that there's a lot of corrosion in this area from the Varta battery. And one of the first things I'd obviously want to do is to take off the battery. And you can see obviously it's gone here. So I did do that pretty much straight away. Once that was done, I then went through and cleaned off all of the electrolyte that I could see using white vinegar. White vinegar will neutralize the base in the electrolyte and get it back to a neutral state. But then you will have an acid on the board, and you should then try and get that off. You can use alcohol to get off the vinegar. You can also use water if you want to. It's not really a bad idea to actually put this in, immerse it in water and actually wash it with soap. as a detergent to get rid of all of the electrolyte on the board. The only downside of that is obviously will damage the labels possibly, but that can be a little bit of a sacrifice that you might have to make sometimes to just get the board really clean. I think what we'll do now is just to give you a bit more familiarity with this machine is I'm just going to walk you through the main components of this machine. And the reason why I've done that is because later on in this video, we end up looking at some sort of like various areas and, how they all interrelate. And that kind of gives you a better sort of understanding of how this area works in terms of the general operation of the machine. So yeah, let's do that now. Let's have a quick look at how all these parts work together to make the Amiga run. It's not going to be in great depth. Don't worry, I'm not going to show you exactly how an Amiga runs, but I just want to give you an idea of the main chips and how this area sort of fits into the bigger picture of the Amiga 4000. So this is the Amiga 4000 logic board. And before we get more specific about the individual chips and so on, I just want to give you a quick overview of the entire board. Before I do that, this is not a definitive guide. This is just to give you an idea of the basic areas of the board and the chips. It helps you to understand really where you may be finding problems and how to diagnose them. At the end of the day, to really diagnose things though, you have to get out a multimeter or ideally an oscilloscope as well and actually check traces and see if you've got activity and so on and so forth. Some of those things I didn't have actually when I started working on this. I only had a multimeter so I could check for voltages and continuity and things like that. But even a multimeter is fantastic because continuity is one of the biggest problems. Things will break, traces will break, and then, chips won't be able to talk to each other and the machine won't work. The areas on this board, like I said, they're general, right? It's not a definitive guide. And you've got to bear in mind that chips reach out everywhere to each other. It's a giant web of connections. And you can see that if you look at the board, it's this massive bundle of wires going everywhere. So yeah, anyway, that being said, the first area on the board is at the top in this particular view, and it is the power and CPU and ROMs. Obviously, the power is somewhere where you want to check straight away, make sure that the power is coming in. Obviously, you want to check the power supply beforehand, make sure that the rails on the power supply are supplying the right voltage on the right wires. Obviously, if you feed in too high a voltage into the board, it's going to explode. And if it's too low, it's just not going to work. So that's an important thing. The CPU slot is there. It's not actually the CPU. That's on a separate daughter board, and we'll be looking at that in a minute. And then directly underneath the slot, you can see you've got the two system ROMs. If either of those ROMs fail, the machine isn't going to boot. It's not going to have its kickstart. So that's obviously a key area of failure as well. Then we have the floppy and IDE area. This isn't so crucial, obviously. If the floppy disk doesn't work, it's not going to work, but the machine's still going to run. Same thing with the IDE. In the long term, obviously, if you want to use the machine productively, you're going to need probably the floppy drive at least. And definitely you're going to need the ID controller. Except that with this Amiga 4000, you do have the expansion boards. So if the ID controller was broken, you could actually put it in an expansion board and sidestep that issue that way. But it's nice to have the inbuilt interface on the board working. So the chips in this area are related to it, I believe. I haven't checked these exhaustively. The only way you can really do that is with PCB Explorer and, checking the pins and when they connect all together. But this is basically the area where the floppy and ID are. And if you have a look on the left there, you see it's going over to that port outside the machine. That's actually the external floppy disk drive connector. So it makes sense that that set of circuitry there is to do with that. Then over here, we have the RAM system. So on the Amiga, it's quite a complex system of RAM actually. And it has two main types of RAM. On the older Amigas, there was a third type, but generally on these, I think there's only two on the Amiga 4000s. There's chip RAM, and the chip RAM slot is the top slot of the SIM slots that you can see there. And then the 4 slots underneath it, they're for fast RAM. What's the difference? Okay, so you can think of chip RAM as being a bit like VRAM that we have today, which is specific RAM only for use by the graphics card. But on the Amiga chipset, there are a number of custom chips, and they all use RAM to one degree or another. They can only use, as far as I understand it, chip RAM. So the graphics system, the sound system, they can only really do their magic with chip RAM. So if your machine has less chip RAM, it is less capable. It can do less resolutions in terms of bitmaps, screen resolutions. You would have less space, I think, as well for sound, as well for music and sound samples. So if your machine doesn't have any chip RAM in it, it's not going to boot. And if it's running, in other words, if the CPU is working, you will get a green screen that indicates that it's running, which is a good sign actually. If you get to the point where you've got a green screen, you're in pretty good shape because you know that the CPU is running and the system's generally running, the clock is running, you know it's getting power. There's so many different things there that, you know, are good about the green screen. The only bad thing is you don't have any chip RAM. Pop a suitable SIM in that chip RAM slot, and if that chip SIM is actually okay, the machine should then boot, or at least, you know, get to the boot screen. Underneath, as I said, the chip RAM SIM slot, there are 4 slots for fast RAM. And fast RAM is accessible only by the CPU, as far as I understand, as well as maybe possibly disk drives and things like that if it's using DMA. I'm not sure about that. Also, the expansion cards probably have some kind of access to it using DMA and so on. But the fast RAM actually is crucial to the operation of the machine. The Amiga 4000 in particular is a very fast machine if it has fast RAM. If it doesn't have fast RAM, it's actually really dog slow. What I mean by dog slow is, and I no disrespect to the Amiga 500, but it's actually the same speed as the Amiga 500, which is a bit of a shocker. But I have experience of this, and that's the case. You can try it yourself if you have an Amiga 4000. Just put chip RAM in and benchmark it, and you'll see it actually runs really, really slowly. So yeah, the fast RAM is, you know, key really to the machine running at its, you know, full speed. Over to the left here, we have the Amiga custom chips. Now, when I say that, one of the chips in the RAM area was actually a custom chip as well, called Ramsey. But these chips in this area, they were in the machine from the beginning, as far as I know. There's a couple of variations. Some of the chips here have changed, and over the generations, there's a new graphics chip in the Amiga 4000, and I think the 1200 as well had the same chip. But what these chips give you are basically graphics and sound, and then there are a bunch of different chips for doing, you know, glue logic and bus arbitration and things like that. So these are kind of like the heart and soul of the Amiga because they give you all this extra ability, like the ability to do windows scrolling up and down easily, the high quality sound for its time. You know, the Amiga, when it came out, had a really good sound chip, had a really good graphics chip as well. This is where they reside on this particular board. Down here, we have something which will become a little bit more crucial to us. This is where the battery is. You can see the battery's on the right there, and you can see there's some electrolytic damage there. Just above it is the Ricoh real-time clock chip. And that gives you your system time. You know, when you load up the machine and you say what time it is, that's what's actually calculating that time. That can break, obviously, and then that's not critical. The machine's still going to work. There is a chip there, though, that actually does carry the system clock. In other words, the clock that is ticking at 50 megahertz that keeps the machine running at a specific beat. If that has gone there, the machine's not going to work. And in various other places on the board, you'll find that you'll have that same clock running through. So you've got to make sure that clock is working and getting to everywhere. And if it doesn't, then you're going to find you probably have problems. The bottom left of that little area, there's a set of jumpers, and they're also important. If there's a problem with those, you're going to have a problem with your Alice chip, and the machine's going to have weird bugs. And I think also it can cause issues with the mouse and joystick input as well. So yeah, in our particular case, in this repair, that's an area where we're going to have a lot of issues, really. Finally, we have the external I/O connectors. These are not generally crucial to the machine working. They're pretty crucial to whatever it is you want to do. I mean, if the sound connectors there, the red and white jacks, if they're not working, you're not going to have any sound. I think directly next to them is I think it might be the monitor port, the RGB. If that's not working, you're not going to have any graphics. So they're not vital really, to the machine working, but each one of these is obviously important to use of the machine. So yeah, you might have to fix these. Now in this particular case, these are all working fine as far as I know. Haven't actually fully tested these, but they're so far away from the damage on this machine, I really don't think they're going to be a problem. So if we go back to the CPU slot, it's at the top of the logic board here. The main thing I would point out is above the slot, there are a bunch of different resistors. They terminate the signals coming out of the CPU as far as I'm aware. So one thing I did actually do when I was checking this was I made sure that they were actually working. There was continuity there. I don't know why I felt that might be a problem, but I did check that. Yeah, that's an important thing. Obviously, it's a very dense slot. It's got a lot of connections, but it's not the CPU itself. So for that, we actually need to have a look at the daughter board. This is the daughter board. In this case, this is the 68040 version that you can see at the bottom of the screen there, A3640 board, revision 3.1, the original Commodore manufactured board. What are the key components that we can see on this board? Well, the first thing we can see is top right. That's the 68040 CPU. This one has a heatsink on it. I'm not sure if that was applied by Commodore, if that was something which is added afterwards. There's nothing much really to say about this. You could replace it with a different one if it was broken, if you found out that that wasn't an issue. In my case, it turned out that the CPU was functioning absolutely perfectly fine, so that really wasn't a problem for me. On the left here, we have the clock crystal, and this runs at 50 megahertz in this particular board, and it is then divided by 2 to give the actual speed of the 68040 processor, 25 megahertz on this machine. Obviously, if there was a problem with that crystal, then that's going to kill this board. It would be quite an easy fix to take this out and put a new one in. I'm just showing it for completeness, really. I don't think it's a common point of failure, but I just thought it was worth showing. Next, we have the capacitors. I'm only highlighting a few here. And the reason why I'm showing these 3 is that apparently when Commodore built this board, the capacitors were defined in the silkscreen actually facing the wrong way. So obviously they were then installed incorrectly at the factory. So it's now common practice to actually reverse these when you're recapping this board. As I got this recapped, I did actually do that. So my actual capacitors now are facing the opposite direction to the capacitors that you see here, which fixed that issue. My board was actually leaking a bit. I did actually start to see some electrolyte coming out of these capacitors, so it was important to get this board recapped. And I felt that because this was leaking, pretty much all the other capacitors, the surface mount capacitors of this generation, would probably be leaking on the board. So I decided to get the board completely recapped. Another thing which I would like to point out is these GAL. I'm not sure if these are GALs or PALs, but they're logic chips which can be programmed, as you can see there. And these actually, as far as I understand it, do the bus arbitration between the CPU and the main bus of the Amiga. So obviously these are very important. And what I found is that when the machine's running, these chips get extremely hot. I'm not sure if that's an issue, but I'm planning to actually put heat sinks on at least some of them, because there are 1 or 2 of them get very, very hot, burning to touch. So I don't think that's a good thing really for a chip to be running that hot. So I would actually like to get some heat sinks on them. Obviously to do that, I'm going to have to take these labels off, which is not so good, but we know what these are because we have documentation for these chips now. So I don't really have to worry about what they are and keep these labels. So I think that's a good move to actually get these fixed. Okay, back onto the main board. And what I want to show you next is the system ROMs. I mentioned earlier that if these are faulty, and they do go faulty in some of these older machines, I don't know why, these can actually be non-functional, one of them at least anyway, and then your machine isn't going to boot. It's not going to do anything. Because the CPU, when it starts up, it will go into the ROMs and get the data to start running the machine. And its own self-tests, I would imagine, are actually on the ROMs. So the self-test that would tell you, for instance, that the chip RAM isn't working isn't going to work if you don't have the ROMs. So I would probably say that's a point of failure in some of these machines. But in my machine, it turned out that these ROMs were actually okay. Over here, you have the Ramsey chip. This is actually connected to all of the RAM chips in the sim sockets, which we'll be looking at in a few seconds. This is one of the custom chips. Obviously, if this were to fail, you wouldn't have any, I think, RAM. I'm not sure if it would be fast RAM or chip RAM. I think it's fast RAM that this actually looks after. But obviously, that's pretty critical to the running of the machine. And then we have this riser card. So this is a very important part of the machine if you want to have expansions, because this is where the riser card plugs into. And I'll just show you the riser card. This is mine. And I found that when I got the machine, there was a little bit of corrosion which had gotten into the riser card slot. I could see that quite clearly. Luckily, there wasn't a lot of it. I cleaned it off with vinegar at first to neutralize it, and then IPA to clean that off and get it clean. And I think I've been lucky. I think my riser card is actually in working condition. I don't think there's anything wrong with it. Fingers crossed, because, I do want to put some expansions in this machine. In particular, I want to put the G2 image engine in and see if I can get that running, because that looks like a really great card, and I'm really looking forward to try and see what that actually does, because it was a very high-end broadcast card back in the day. So I think that would be really interesting. One thing I would note on this board, it does have a few capacitors. I have seen other people's videos where they've found those are leaking. In my particular board, they're not, but maybe something to keep an eye on in the future. Maybe at some point I'll get it recapped, but right now, none of the capacitors on my riser card are leaking, so I'm just going to leave them as they are for now. So this is the main area of drama on this machine, and the main causer of the drama is the Varta battery, or as I've dubbed it, I am become Varta, Destroyer of Amigas. It's got that name for a good reason. It really is an absolute swine in terms of destroying Amiga 4000s. It also caused a massive amount of damage to my Amiga 2000 as well. In the Amiga 2000, it's right next to the CPU, which is great. It's kind of right next to some lines that come out of the CPU, go over to the ROMs, and then those same lines go off to the left to the CPU slot. It's a common cause of failure on the Amiga 2000 that the Vata battery will actually cut those connections and the machine can't get to the ROMs and it just won't boot. It just black screens. Once you've got those lines reconnected, you'll find generally the machine works. And in the Amiga 4000's case, though, it's probably worse, to be honest. So you can see there on the logic board, there's a lot of electrolyte damage, the actual PCB. You can see it's gone a lighter color. And I'm going to show you these lines because what I want to try to indicate to you is that there are kind of two main ways that the electrolyte sort of spreads across the logic board and can cause damage. My machine, I think, was lying on its opposite side to the edge of the board that we're looking at here. So where you see those yellow lines going upwards, that was actually downwards, if that makes sense. The red lines, they represent the creep of the electrolyte across the logic board through some kind of capillary action mechanism. Not quite sure how it works, but it's like a wave that spreads out from the point of leakage. I suppose it's a bit like you can imagine if you poured a syrup on a very smooth surface, it would slowly spread out, very, 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 very slowly. And I think that's the way the electrolyte works. It kind of slowly spreads out from the point that it's actually coming out of. And it's a kind of greasy liquid. So that kind of makes sense that it's this kind of syrupy, very slow spread in a kind of circular manner, I suppose, when the machine's lying flat. The yellow lines, what they represent is where the electrolyte is kind of trickling down, more like a sort of waterfall, I suppose. A very slow waterfall, I would imagine. But that's what I found on my machine. I found that I had this circular spread of electrolyte from that point on the right-hand side where the battery leaked. And I also had this elongated area of spread where it seems to have been running down the machine. And it must have been like that because it got onto the riser card slot, which you can see at the top of the image there. Not good. And what I'm going to show you now is the octal transceiver. So that's the chip, which is very close to the Vata battery there. And it's actually one of the chips, and I've actually highlighted several of them here. But the one with the label is the one which is in the way of most peril. It's right in the way of the Vata battery. And in my case, the electrolyte seems to have flowed directly towards it. That particular octal transceiver there, plus the capacitor that you can see there, they both got quite a lot of damage. There are also some other traces which go across that area, and you can imagine those would be pretty damaged by the bathing in electrolyte that actually took place over, I don't know, months, maybe years. Further up the run, or rather further down the run where the electrolyte would run, you've got the SuperBuster. This is I think it stands for bus arbitrator, but this is the chip that actually allows the expansion cards on the expansion riser that we just showed you to actually function. So if you want to have any expansion cards working in the machine, then the SuperBuster is obviously very important. I have a SuperBuster 9, which I understand is actually a buggy variant, one of the earlier variants. And Commodore produced a Buster 11 at least. I don't know if there was a 10, but I think 11 was the ultimate version that they did. And if I want to use certain expansion cards in this machine, I have to replace this Buster 9 with a Buster 11. So it looks like my future has me buying a Buster 11 and replacing this one. This one actually works, so for now, it's okay. There was some corrosion on it from the electrolyte, and to the right of it, there are a bunch of wires there which were oxidizing from electrolyte. I've cleaned them very thoroughly, and I've cleaned this chip. I've taken it out of the socket and neutralized the electrolyte and cleaned it and so on. And I also washed this area of the board a lot with alcohol to try and get rid of any residue of electrolyte. So fingers crossed the SuperBuster is completely functional and there isn't any major damage to it. Next, the chip and fast RAM slots. These are obviously pretty critical. The chip RAM luckily is quite far up the board, but it is kind of in line with the electrolyte leakage. So we need to make sure that we clean the left-hand side of that chip slot, which is the one at the top there. And then as we go progressively down the slots towards the edge of the board, especially towards the left-hand side, that area of each of those slots is obviously in a lot of peril because it's right next to the electrolyte. We'll find later that that did have an impact on the functionality of those slots. Then we have the U177 clock. We'll have a look at this in a little bit more detail in a second. I just want to highlight where it is there, right next to the Vata battery, obviously a candidate for a lot of damage. But in this case, I was lucky because most of the electrolyte actually flowed away from it, but there was some creeping electrolyte that went across the surface of the board, and it did cause a little bit of damage to this clock. However, I think I was lucky. I don't think there was really that much damage. And to the left of that, then we have the U976 chip. And then there are the headers to the left of it, where jumpers can go to do configuration. And also below it, there are a set of resistors, which then drag those signals low. If any of those are damaged, those resistors, and they can be, if you were to have your machine lying, with its back of the machine used as the actual base, then the fluid would flow to the left, right, and would actually hit all those chips. And that can cause some pretty nasty damage as well. So we've zoomed in on that area. I'm just going to highlight to you, you can see here the Varta battery footprint. To the left of it, we've actually got the clock chip. This is the chip which has the system clock rather than the real-time clock. If you look at it there, this is after cleaning it up. The left-hand side of it, the pins look relatively shiny after cleaning. The right-hand side, they still look relatively shiny. I don't seem to have lost any traces. All of the pins are intact. They're looking a bit pitted, to be honest. They have taken some damage. But this chip, I think we've got away with it. I think we're lucky in this particular case. To the left of it, I've highlighted the configuration chip as far as I understand it works. This chip actually looks in better condition. If you look at the pins, they're not looking pitted at all. And if you look at the traces next to it, they're actually looking pretty good, actually. They're all looking pretty clean. The previous chip, I think the traces they look a little bit dodgy, to be honest, and they may fail in the future. I have cleaned them, but you never know. Electrolyte might have got into the board and it could be causing damage to those. But for now, it's working fine. So yeah, if this isn't working, you're going to have weird things going on. I think it's with your Alice chip. The machine will think that you have a different Alice chip to the one you actually have, and then it will act accordingly and you'll get weird bugs and it won't function correctly. So it's important that this chip and the resistors that you see below it are actually in working condition. And in my machine, I think I've been lucky in that regard. They seem to be fine. And then above those two chips, we have a resistor pack. And you can see on the base of that, it's actually, you've got some silver there. So that's actually okay. Yeah, I think we got away with things in this area, but there is potential in the future possibly to have other failures, but at least I know about it in this area and I'll know how to fix it, where to put bodge wires in to fix this area if it does have a problem in the future. Okay, so where do we find ourselves? Well, at this point, the logic board is clean. We've used white vinegar, alcohol to get off the vinegar once that's been done. And yeah, that part of the process is out of the way. The battery has obviously been removed, and we found, quite severe damage in this area from the battery, unfortunately. So we know that we're going to have to do some repairs. I noticed that the surface mount capacitors were leaking. It was very mild. It looked like it kind of just started, actually. There was a little bit of evidence in this area where the traces were looking a little bit dull in this area. And I noticed a few of the capacitors on the CPU board here, on the daughter board, were actually looking like they were leaking as well. I knew that these capacitors were in the wrong orientation anyway, so they needed to be taken off and put back on. Obviously, with new capacitors, that would make sense. Was I going to do that myself? Well, this was it is a very valuable machine, and I decided that I wasn't going to learn how to do surface mount capacitor replacement on this machine. This is very precious to me because, I had one of these machines back in the 90s. I'd made a big effort to get this machine and I really didn't want to destroy it myself. That would have been a horrible outcome to the story, wouldn't it? So I looked around on the internet to see if there were any local services that could do this for me. And funnily enough, it turns out that I live very close to Analogic. They are an electronics supplier and repair facility. And it looks like they were a dealer of Amigas back in the 1990s. They seem to have a large stock of old machines there, new old stock, I should say. And they are one of the main traders these days in actually selling replacement parts for Amigas. They have all the custom chips, especially, for instance, for the Amiga 4000. They actually have quite a lot of these, as I understand it. So if I wanted to get a Super Buster 11, that would be probably the company that I go to do that. So I took the machine over there. I called them up beforehand to ask if they could do it, and they said they could. I took the machine over there. I had a nice chat with the owner. He's a really nice guy. And it took, I think, about a day for it to be recapped. I actually supplied the caps. I got them, I think, from Amiga Kit. It was in a little bag, pre-prepared, all the right sizes for the job. And the owner gave me some advice. He said, if you're going to do bodge wires, which you could see I probably had to do, he said you should use magnet wire. So he'd actually give me a little bundle of it. And this was probably like 0.5 millimeter thick, maybe even less. And it's coated with an enamel, which means it's obviously insulated. But the enamel will burn off when you actually solder it. So that's quite cool. You can solder it at the end, solder it at the other end, and it should be insulated along its length, but then you'll have continuity at either end. And in the next video, we're actually going to look at how I did those repairs, those bodges, and you'll see that magnet wire actually being used there. So let's have a quick recap of what we found in terms of damage before we finish this video. We know that the battery caused damage. We saw it leaking in this direction. I think we nipped the damage in the bud with the Super Buster and the chips in this area. We cleaned that, and that has fixed things, hopefully. There's some obvious damage here on SIM slot 3. There are 4 slots, 0, 1, 2, 3. And the pins in this area took a real dousing in electrolyte, and I think they were almost certainly gone. So it looks like we're going to have to repair those pins, get continuity back between slot 3 and slot 2. We also noticed there were 3 traces in front of this capacitor here. And I didn't know what they were, but using PCB Explorer, I discovered that one of them is actually very important to the functionality of the fast RAM. So that would definitely need to be fixed. And then the other 2 are kind of optional. We'll look at that in the next video, and they all got fixed. So don't worry, I didn't leave anything undone there. And then the other thing which was very concerning was this chip here, the octal transceiver. That is actually involved with a bunch of other octal transceivers here to actually run the fast RAM on the machine. You know, that would obviously need to be fixed if any of these traces were broken. So before we finish off, what was the state of play of this machine? Well, I took the case off the power supply, made sure it was unplugged first, looked inside, and I could see that there was nothing really wrong with any of the capacitors. They looked okay. Closed the case back up. Then I tested the rails on the power supply, made sure that it had all the right rails, you know, and it looked fine. I couldn't see any problem with the power supply. So that's really cool. I then connected up the machine, put this in. I got an RGB to SCART cable, and I connected it to my monitor. And I'd already tested that quite recently with an Amiga 500. I knew the cable worked and the monitor worked, so that wasn't going to give me any false feedback. Turned the machine on and got a completely black screen. So yeah, that was a horrible moment where, you know, you realize that you've spent so much money on this machine, you've traveled, you know, you spent, what, 5 hours in a car, and it's dead as a dodo. So yeah, you know, it's a pretty disappointing state of play, but there we are, that's what it is. I'm a big believer, you know, as a software engineer, that you can have a massive problem. This appears to be a massive problem, right? I'm never going to be able to work out how this machine works. That's not necessarily true. You just need to use Occam's razor and say to yourself, you know, what are the obvious things that are not working here? And if you fix those things, the machine very often will start working. And if it doesn't, you then have to go to the next level and then the next level. I think it's quite a good way to work. Never go to the, you know, the depths of logic analysis until you fix the obvious problems. And there were quite obvious, you know, obvious problems on this machine. So that's what we're going to be looking at in the next video. I hope you've enjoyed this video, and I hope it's been instructive. And if you have, please like the video, because it'll obviously help it to be recommended to other people out there in YouTube land. If you like this series, please subscribe, obviously. I want you to come back and see the rest of the series and hopefully see its hopefully positive conclusion. Yeah, you know, I hope you've enjoyed this video, and I hope to see you in the next one, where we look at the repair of this machine.